Today we have our first lecture on Introduction to Programming. We will be using the Python programming language, and we will talk about variables declarations as well as flow control and input-output operations. So what we have here on this picture is just a visualization about what is computer programming. So we have some problem that we would like to solve, and computers would help us to solve this problem, as they can do computations for us and help us to solve the problem quicker or easier than it would be without a computer. So the computer allows us to give commands to the computer, let it do certain computations step by step to solve our problems. So a certain algorithm will be applied in line by line, and then logically we can visualize the problem solution as a flowchart. We would use a high-level programming language to tell the computer what to do, that is, issue commands in order to implement this algorithm and solve the problem. Once we have written the high-level code, it gets converted into what is called a machine language, or it gets compiled into instructions that the CPU understands. The central processing unit of the computer understands. So the CPU of the computer runs a specific instruction set that's called assembly language or machine language, and any kind of high-level programming code written by us, the programmers, would get converted into this assembly language or machine language so that the computer's CPU can execute this code and then solve the problem. So the idea here is that we have the solution to our problem, and that is why we are writing all of these computer programs. So what can be a problem? For example, it could be we would like to keep all the student records into a database so that we know which student is enrolled in which class and what grades they accomplished in this class. Or they can be used by other domains like financial banks. Banks want to keep the records of their bank accounts for their customers and their financial transactions. Medical institutions want to keep medical records for their patients and the treatments that was done on these patients to heal them. Government might want to keep people's taxes and other government information, or military might want to keep their information in the computer. So all of these are computer programs that assists us to solve certain problems. So the Python programming language we would be using, there are many other languages that exist, such as C, C++, C#, Java, in addition to Python. We would use Python because it's easy, it's simple, and it has plenty of libraries, scientific libraries, artificial intelligence libraries, machine learning libraries that we can call to solve various problems. So to write the code in Python, what do we need to do? Well, first of all, we need some text editor or an IDE, what is called integrated development environment. So we need somewhere to write our code, pretty much like a notepad, a text editor of some sort, to where we would write our code. We also need a place to where we will be compiling the code, because we mentioned that the code needs to be converted to machine language in order for the computer to understand and execute it. So the IDE, Integrated Development Environment, provides us a text editor to write the code, as well as a compiler to compile the code and convert it to assembly language. These are some example IDEs that you can download and use them. We would be using an online one called Online DGB or Online Debugger for this course. So you would see this into the assignment instructions. The reason we use the online one is so that you don't have to worry about installing Python Anaconda runtime environments onto your computer, because some computers have problems installing those. They have certain memory and CPU requirements, or you might have an old installation that needs to be overwritten, and you don't have to worry about any of that by using the online compiler. Also, it lets us easily share the code with professor and with other students by providing a link to our code. Okay, please everyone mute your microphones, because we are recording this and we want to have a good clean recording for the people, so people can listen to it later on. Okay, learning objectives. What we will learn in today's class. Could you please mute your microphones, guys? Let me see here who is still not muted. Okay, everybody's muted right now. Okay, so we will describe fundamentals programming of computer science terminology. We'll explain the basic structure of Python program. We would be able to write, compile, and execute a code, simple Python program code. We will be just printing a hello world message on the screen. That is, the classic computer programming first assignment. Print a hello world onto the screen. Okay. And we review the basic software development process. Alright, so programming. What is programming? We will break down a larger problem into smaller pieces until it is simple enough so that it can be easily implemented by us, the programmers, using the programming language. That is, the solution to the problem can be easily implemented. What is instructions? We mentioned already. This is assembly level instruction set that the CPU understands and executes. So every computer has instruction set that it understands and executes. So our program will be converted into a sequence of this machine level or assembly level instructions, and that is what a computer program is. Here are some examples of instructions. input-output instructions. This means computer needs to be able to read the keyboard or whatever. If we are writing some commands through the keyboard, that's input. So he needs to be able to understand the input devices. The input might become something a touch screen for something else. The output is when, what did we say here? We will be printing a message onto the screen. We will be printing hello world as an output from our code. Our program is going to create an output which will be the message hello world. From there on, it can also create an output file and save the hello world into a file. So from there on, there are a number of libraries that already exists in the Python programming language or whatever programming language you'll be using. There can be scientific libraries like math, add, subtract, divide. They could be logical operators and or comparison operators. Is this equal, smaller, or bigger than another number or text? Or they could be more complex, such as machine learning ones. Does this patient have a heart disease or not? Is this customer high risk or low risk of repaying their credit cards? Does this student meet the admission requirements for our college or not? So there could be some decision-making process in libraries, machine learning or artificial intelligence. Certain functions sometimes would repeat, or these are called recursive functions, because they need to iterate. This means they need to scan a database multiple times in order to make these decisions that we described earlier. To reduce the problem into smaller pieces, they need to repeat what they're doing multiple times until all the data has been processed. So once again, we mentioned earlier, what is the point of having these computer programs? It's because we want the machine to help the humans to solve their problems. So the machines are intended to carry out any operations that can be done by a human to make them quicker or easier to do. Looking back at some computer history, this is how computers used to look like when we first invented them. They were huge, they had many buttons, some of them were using punch cards. Like computer programs were done in a form of a punch card that needed to be stuck into a big old machine like this to execute the program. Some programs were later stored on tapes and discs until we got to the more advanced storage solutions that we have of today. So the programs are being stored now in the memory unit and a form of data. And the computers have become really widespread, and so that we can say that they're ubiquitous. This means that they're everywhere around. We have small computers in our watches, in our phones, in our cars. So there's small computers in the cars that would tell if there is if all the car functions are functioning properly, or if we need to pump our tires or replace our oil or do something else with the car, or check the engine of the car, or where we are located, if we need help, roadside assistance or something else. The phones especially would be able to do something like that, as they have the global positioning system apps or applications that are computer programs, of course, that tell us where we're located and allow us to get directions and so on. There are small little computers everywhere around, especially like if we go to airports and you have the doors opening automatically, so there are certain sensors that these are small computers that tell someone wants to walk through the door, so they open the door or adjust the lights or turn on the water faucets in the restrooms. So there are little sensors all around us. That's what we mean by these computers have become ubiquitous. Let's look at programming languages. To make this a little bit bigger so that we can see it better. So, programming languages. We are going to be using the Python language in this class, but there are other languages that are popular and very widespread. For example, the Java, C and C++. These are, I would say, the first programming languages that computer programmers really should be learning, C and C++, and Java after that. The reason for that being because if you have a computer, let's say a Windows computer or a Mac computer, the operating system, the foundation of this computer, is written in C language. The operating system of the Mac or the Windows, it's written in C language, as well as the network that connects this computer to the internet is written in C language. So that's why we need to start with this language as computer programmers. Originally, C++ is a more advanced version of C that has some additional features, but C is really like the core language that is just about everywhere. Your phones, all of the cell phones operating iOS, the Google OS, it's all written in C. Okay, so C# is more like a Java. That is like a Microsoft version of Java. Okay, C is the reason these are all written in C is because it allows us some low-level control over the way the memory is handled, the way the device drivers are all written in C, like for the keyboard, for the monitors, for phones being connected to computers, anything you want to plug into the computer. Drivers are written in C, so it allows us some low-level control to the memory and disks, drivers, CPU to the core of the operating system, and allows us control over the way the trash is handled. This means memory allocation and deallocation. So it allows for much faster running code to be in the core of the operating system. Now, Java is a more advanced language. This means it's easier to use. It has some ready available libraries and other things that C and C++ don't have. Like the Java would make the programmer's life easier by handling these trashes automatically. See, we don't have to worry about deallocating all the memories. The Java trash collector will do it automatically. But because it does that, it's much slower to run. So if we are to write an operating system in Java, it will be running much slower than the ones that run in C and C++. Python is a language that's much easier than any of those other ones that you see here. So many schools prefer to start with Python because it's just easier for the students to learn it to begin with. And the reason Python being easier is because of it's just much simpler, let's say, to declare variables. Over here you have to say, before declaring a variable, I have to say, is this a number? Is this a text? Well, if it's a number, is it a 32-bit number or 64-bit number? Because if it's 32, I can say it's an integer. If it's 64, much bigger, I have to say it's bigger number, it's a double. If it's a floating point, I have to say it's a floating point. If this is a text, I have to say, is it a text long one or is it just one character? All of that stuff needs to be specified to declare the variable. You see, Python doesn't have this problem. You just say variable. And they're on. You can be numbers, texts, arrays, whatever you want. No need to specify it. That Python will figure this out automatically. So that's why it's an easier language to use. This JavaScript and to learn for students, for beginners, okay. Now, JavaScript is more of a web programming language for writing web pages or web interfaces, and specifically more on the client side of things. The client side of the web interface. This orange color. Okay, do we have a question here, or feel free to unmute yourself if you like to ask a question?
Hi, Professor. This is George Esperance. Good evening. I had dropped a question in the chat box, and I raised my hand just in case you didn't see it. You emphasized, you mentioned that C and C++, I think these are like foundational languages, because that's what the operating systems are written in. I'm curious as to why, since these languages are so foundational, they're not included in the computer science program, but Python instead.
Yeah, I just explained that. So the Python is easier for students to understand as beginners. And also it has become a popular language to where it has multiple libraries that are easy to call them and use them. While if we're to do this, we have to write these libraries from scratch ourselves. So many colleges or schools would prefer to start with Python because it's easier for students to learn, and it has those extra functions that are readily available to just call them and use them. Okay, so combination of keywords and a special...
Sorry, I have a quick follow-up, if you don't mind.
No, we will ask questions at the end as I'm recording this, so...
At the end, okay, I'm sorry.
Please hold your questions to the end. Combination of keywords and special syntax would be used. It will be easier for humans to understand. And it's portable language that can run on different computer platforms or architectures. So this portable language is especially true about Java because the Java was designed to run on multiple platforms. So let's say we're going to write a computer program and we have a Windows computer. If this is written in C and gets compiled, it will produce an executable file that only runs on Windows. So you can't take this program and run it on a Mac or on a Chromebook or something else. No, it only runs on Windows. You see, with Java, it was designed, we would compile this into what's called an intermediate level language. So it's half compiled, half uncompiled, and when it gets to the right computer where we would be running it, it gets finished off to that specific computer system. So then whatever is written in Java, it can run on any platform. So this is about the high-level languages. Low-level languages that we mentioned earlier, such as the assembly language. We could write computer programs straightly into assembly language, so they don't need to be compiled, but they will right away be in a language that the CPU would be executing. We could do that if we wanted to, if we have some simple task, such as basic mathematics or basic reading and writing into a file or something like this. We could do it in assembly language, but if we have some more complex task, it will be easier for us as programmers to write in a high-level language. It will be quicker and easier for us. Whatever it is that we are writing, it all gonna get converted to assembly language, because that is the language that the CPU understands and that it will be executing. So machine language is when it gets down to zeros and ones. Basically, it gets converted into binary. Everything gets converted into binary eventually, and computers are designed really to just read zeros and ones and the end. Okay, so the program, once we write the program into the high-level language, as we mentioned, it needs to be compiled. If it is something that will run on multiple platforms, it gets converted to intermediate language by interpreter. So Java program would be using an interpreter, because we mentioned that the Java program needs to run on any operating system. If it is any of the others, it will use a compiler. This means it straightly converts it into assembly language and machine language instead of using some intermediate language. So, source code is there. That is what we will be writing. Compiler comes in, converts it to assembly language and machine language. Then the CPU can run this, and the way it will run it is line by line. So it really runs it in sequential order, line by line, and until it gets to the end of the program, and then it can convert produce the output. So really, one CPU can only run one program at a time. If we're wanting the CPU to run a couple of programs, let's say we want to have a PowerPoint and a Zoom and a web browser and a text message, then he can't really run all those at the same time. But what we can do is give like a small fraction of the CPU time to each program, put them like in a round robin fashion, and let him run each program for a split second and then go to the next one, and it makes it look like they all run at the same time. Or we can have multiple CPUs, a CPU with 4 cores or with 8 cores, and then each CPU core will be running one program simultaneously. Alright, so now we will go to write our first code here. We would write our Hello World program here. So what is an algorithm? It is a sequence of tasks that we would perform in order to solve our problem. So sequence of steps to solve the problem. Okay, so I would like you all to, since we want to start with our first program, I would like you all to go to onlinegdb.com, select Python 3 from the language drop down, and run the Hello World program. And then go ahead and click share to get a link to your code. And also click save to save your program and register an account. Okay, we would like to take 5 minutes for everybody to do this so we can run a Hello World program. Okay, so let's look at the Hello World program. Let's get my browser here. So we're gonna go to onlinegdb.com. This means online debugger. From here, we want to select Python. As you can see, this is in C. This is in C language. So from here you want to select Python 3, and then you have your question answered. It's so much easier. There's only one line here. It's much simpler language, Python. And this is the code. There's one line of code right here. Everything else is comments. And we want to run this. When we click run, it will compile it. This means will be get converted into assembly language and machine language. Then the CPU would execute our instruction, and there you go. This is the output. It printed hello world into the screen. From here, you want to click share, because that's how you'll be doing the assignments for this class. The assignment would ask you to compile the codes here, create a link, and submit this link onto the canvas for your assignment. So you would click share, it'll create a link. So if I copy this link, anybody who has this link, your professor or somebody from your group, can come up here, and here's your code. And they can run it and do whatever they want with it. And then click save so that you can save your programs. You would need to create an account and log in, and from there on, any codes you write will be saved. Alright, so the algorithm will be the sequence of steps on how to solve a problem. So when we are doing our assignments for our class, we would be pretty much creating an algorithm. We would be thinking about what would be the steps to solve the problem that is given in our assignment. So effectively, we would be creating an algorithm to provide the solution to the problem in the assignment. We have just seen the print hello world into our first code there. We can print more things. How are you? What is your name? We can tell it to print the stuff into an output file instead of printing it on the screen. And then if there you go. You want to print for the first line with print Paul, the next one BAM, the last one zip. We can tell it, instead of printing this onto the screen, print it and save it into an output file, text file of some kind. Now, if within our code we want to save these things, say we want to have a variable named Paul or a variable named zip, then we have to declare a variable. The reason it's called variable is because we can make it equal to anything we want. So that's why it varies, and it's called variable. They can be a kitchen plate, a hammer, or some other toy, or whatever we want it to be. A number, a text. So in Python, to declare the variable, it's very easy. You just give it a name. What is this? A kitchen plate, a toy, or a hammer? You can call it whatever you want. And then we need to give its value. What is it equal to right now? So for example, our variable is called score and it's equal to 5. If we didn't tell it what it's equal to, it will still declare it. That is, Python or whatever language we're using, he will still declare the variable. This means it's gonna save space into the computer's memory for this variable. But what is it equal to? Nothing. It will be equal to some random junk, whatever happens to be in the memory location that is assigned to this variable. That's why it's good for us to initialize the variable by giving it some value. We can say equal to 0, at least it will be a 0 instead of random junk. So that's why it's good to say what we want it to be equal to. So then we can print it. Print score, and it will print the number 5 because score is equal to 5. If you want to see the random junk into the memory, then don't initialize it, say print score, and you will see what was happened to be in that memory location, whatever gets printed out. Okay, so here are a couple of variables here. The first one is called score is equal to 5. Next one is h. I would assume that's a height of some sort. 17.4. That's a floating point number. Okay, there we go. So because the Python is the easy language, we are not required to tell the type of the data that this variable is. We just say score equal to 5. But in reality, the data type of score is an integer because it's a number that's equal to 5. It's a whole number. It's about 32 bits number, and because of this, it's an integer of an integer type. If it was a number that has a decimal point, well, that takes a little bit more than 32 bits to represent it into the computer memory. It might take 64 bits, and for that reason, its data type is called floating point number, or a decimal number. So this is a float type. If we want our variable to hold text, this would be called a string. A string is a sequence of characters. So what is a character? Character is the one key from the keyboard. It could be the key A, the key N, it could be the space bar, or the escape character, or some punctuations and symbols. One keystroke is one character. If we're going to have several ones, it will be called a string of characters, such as Anna, A-N-N-A. This one we have 4 characters. Now, if it is some binary number, say 0 or 1, or true or false, it will be called of Boolean type. And these are very much necessary, believe it or not, because once we start doing comparisons, is this number equal to 5 or not? Is this girl's name Anna? Yes or no? So in order to tell that, we need to use the true or false value, which is a Boolean data type. Okay, so here are some specific Python language notations. There are certain keywords that are used by the programming language, such as true and false, else, if, for, class. So these are specific commands that the programming language needs to use, that we should avoid giving our variables a name like that. because we're gonna confuse the programming language if we do that, and it's just gonna give us errors. So avoid calling your variables like this here. Certain built-in functions that the Python language has. Print, as we have seen, we printed this stuff on the screen earlier. We have printed hello world and printed all these things. As you see here, when we type the word print, it comes out in a different color, and that's how you know that this is a command that exists into the Python language, and we should not be naming our variables like that. It just comes out in a different color, so you will know it right away. You don't have to worry about renaming it, remembering these names here. But there are other functions other than print. There are some mathematical functions, square roots, things like this. Maximum, minimum of number, or open and close a file, and things like that. So, as I mentioned, they will just come out in a different color, so you don't have to worry about remembering them. But if something comes up in a different color, this is how you know that that's a reserved function and not to be used for your personal names of your variables. This is out of alignment a little bit. There we go. There are certain symbols that we'll be using. For example, the plus sign is used to add two numbers together. 2 plus 3 will be equal to 5. Minus is used for subtraction, like 4, 3 minus 6. The star or asterisk is used for multiplication. If we want to multiply 4 times 6, we would say 4 star 6. The slash, the forward slash, is used for division. So, for example, 13 divided by 4. Percent is used for remainder. 13 remainder 4. And if we want to put an exponent, like 2 to the power of 3, we would use 2 stars. 2 asterisk asterisk 3. That's 2 to the power of 3. So, by knowing these, we could do a number of mathematical computations easily. Like, if we want to know how much is 2 plus 2 times 5 to the power of 2, then we go here and we write, we can straightly write it as the way you see it. Give it some name here. For example, my variable, and then you say equals to all of that stuff, and it will be computed automatically. It will place the result into this variable, and then you can come out here and say print my variable, and you will see what the result is. Okay, so now we're going to take a 5-minute break. You can think about what questions you have. You can write them in the chat, and then once we come back, we will work on our first assignment.